it is very we don't want to you bring the contaminant with you back home, right? So it is a very important issue to have a healthy and a safety plan and do the SOP properly and precisely. Sure. Okay, wait a second. So I'm from Tech Environmental Technology, and I'm working on the soil and groundwater remediation for about 15 years. Do the science investigation and the focus on the remediation about the chlorinated solvent. And recently, I'm work on the green, sustainable, and resilient remediation. So it's a new term, but I suggest you to consider this part when you doing the wind process remediation. Why? Because you are facing the you are facing the resilient issues. You are facing the climate change issues. You have a monsoon season, and the flooding always comes. Sorry. So okay, I share again. Okay, it's work. So I suggest you to try to touch this issue because it can prevent. It try to force you or make you to considering the climate change, to considering the flooding issues, the raining during the remediation. So it is important. But I won't touch this issue later. So today we spend a lot of time to discuss about the ESA phase 1 and trying to develop the site conceptual model. So the conceptual model to me is trying to develop a relationship between the source to the receptors. It can be text, it can be a table, it can be a data, some data, or like the cartoon 2D or 3D figure. It's just help you to use a very simple method to identify the source and the pathway from the source to the receptors. So you can know the data point where you should tag, and to know what information you should collect from from the site. Okay. So you are from the phase 1, and we are from the phase 1. Go into the phase 2. What's the difference? The difference is to because CSM in this section now is only kind of imagination, right? You never go into the site. You just use the old data. You just use the interview result. You use the aerial photos to see what may happen there. So when you go into the phase 2, the site investigation, you are from suspicion to confirmation. You are trying to confirm what is the contamination, what happened in that site. And if you want to do in a remediation, you will go to the further site investigation, more detailed information to get the information, more specification information, and the precision information. So here's the table. When you do the site assessment, you go to the ESA phase 1 process. You did not taking the sample, and when you go to the phase 2 and the phase 3, you have to taking the sample. So it's intrusive process. You taking the sample, confirm the sample concentration of the contaminant in the soil, groundwater, sediment, or you have to taking some animal samples, tree samples, and try to figure out the risk and or the potential hazard of the surrounding areas. So it's totally different ideas about the phase 1 and the phase 2. So then the following question is, what is a site investigation? Site investigation is a combined method. It could be geological method, it could be hydrogeological method, you could be soil sampling, chemical analysis, or even microbiological analysis. It's a combined method that can help you to identify the description of the characteristic of a land. And the ESA phase 2 science investigation have a very relatively specific definition. It's focused on the contamination distribution and its transportation. And the other purpose is to prepare for the remediation in the soil and groundwater. So all of the technique you can apply in site investigation. There's no procedure. You can use different methods to collecting samples, collecting data, and give you an idea or more comprehensive, detailed information about the site conceptual model. So why we need site investigation? Because in the phase 1, you just see there and you use your imagination or use your expertise to identify potential contamination point. So, but it is only potential, right? It's only potential. You have to confirm. So you have to go into the site, taking a sample, identify the contaminant and its extent, to describe the distribution of the contamination, and trying to clarify the relationship between the contaminant and to the acceptors. So basically, we following the phase 1 result to doing the site investigation plan. So only when the result from the site phase 1 indicated there's potential contaminant, you have to take the sample. And then all of the planning is based on the phase 1 phase 1 report. So it is important. So when you go to the site, please record everything you see, record the situation now, and review the historical information very, very careful. So for example, yesterday, Mitch mentioned cases. So remember, they have a former factories may cause the arsenic, right? So, but in that case, there's a park was developed there, right? So if you notice in his slide, he mentioned the factory cover a clay layer there. So where is the clay layer comes from? Where is the soil comes from? This can be the other sources of arsenic. If they use the contaminated soil and transport the soil to fill up the land, it's caused the arsenic contamination, right? So it is the other. So you have to review the data, review the information very carefully. When you go to the site, it is the situation now. You go to the site, you see the situation now, but not in the past years. So you have to collecting the data, review the data very, very carefully, and trying to use this data, use this information to produce or to planning your following phase 2 sampling procedures and process. So how to do the site investigation plan? So when do the site investigation, it should be very objective. You should, because site investigation always happened during the life cycle of the site. When you first time you go to this site, you're taking the sample, it is the contamination identification process. You have to design a contamination site investigation plan based on the phase 1 data. But when you when you're doing the remediation, you have to redesign your sampling process because you has already know the potential distribution location of the contaminant, and you have to describe more precisely a distribution of the contaminant in the saturated or unsaturated aquifer, and trying to figure out how many volume of the soil you have to excavate, and how many volume of the groundwater you have to treat. So it's totally different idea to doing the site investigation plan. So the most important issues is your object. So your goal, your scopes for the site investigation plan. So this is the flow chart of from phase 1 to phase 2. So in phase 2, you have to set up your scope, your object, and then finally design your site investigation plan. Based on your object, you can choose different tools to help you to understand what happened there. For example, the geophysics methods, you can get a very big profile of the soil and groundwater, potential distribution of the geological information and the contamination. And then you can use the traditional drilling method or borehole method to getting the sample to get the more detail about the distribution of the geological information. And you can use the MIP and the soil sampling, groundwater sampling to confirm the distribution of the contaminations. So it is important to select the tools you used in doing your site investigation plan. Then the other important issues is the QA/QC. So remember, garbage in and garbage out. Use the precise sampling procedure and get the sample in a very stable with a very stable result, and following the QA/QC process to identify what happened to get a good quality information, and you can describe the whole picture of the contamination distribution. And then you can update your site conceptual model, and then doing the following action. So let's three important considerations. One is the objectives. If you what is your object? Well, maybe identify the potential contamination. Maybe you want to more precisely describe the distribution of the contamination and of the boundary and its extents, and or if you want to know the risk of these contaminants, you have to choose different target of the sampling, blah, blah, blah. So you have to considering your object and trying to design your sampling plan. And you have to considering the representative of the your sampling of your sample. So you have the very procedure of each step, especially for the soil sampling and the groundwater sampling, to make your and your analytical process. You have to make the QA/QC system is strong and getting a very stable information product, and you can get the precise answers. And of course, you have to considering the time, the location, and the depth of your sample. Because just remember Dr. Colin Chan's figures of L NAPO and the DNAPO and the heavy metal. They have a different behavior in the soil and groundwater. You have to select a proper location and a proper depth of the sampling, and you can get the more representative result. And of course, the sampling point is important. You should trying to close to the sources, and you can get more higher concentration data. So it can help you to describe the more detail about the site conceptual models. And of course, there's a lot of limitations. You should know the characteristic of your pollutants, and you should understand each technology you choose when you want to apply this method to the site soil sampling or screening tool like SIF. For example, SIF, the arsenic concentration could be interfered by the lead, because they have a very close signal at the certain spectrums. So when the lead concentration is higher, your arsenic concentration may be higher. So when the site was contaminated by the lead, and you use the SIF, you may get a higher concentration of arsenic. So this is because the background interference from the lead, not the actual contaminant is not actually contaminated by arsenic. So it is important to understand the limitation of the tool you use. It is very important. And of course, you have to consider in the safety issues, because if the contaminant is hazardous material and mix each other may cause the vapors or high temperatures, you should be very careful to take care about this kind of sampling. So I think Dr. Fang will talk about this later. And you have to consider in the space and the time of working time you should take, and how your people can go in or not, and how to plan your route during this process. And of course, most important, you have to consider in the time and your budget to select sampling. So I give you a very general subsurface contamination distribution and its sources. So you can see in the factory, the wet producing process is most potential leaking area, or the waste temporal storage area could be the potential potential contamination sources. And the stormwater change or the manhole or the sump could be the other sources, or the above ground storage tank or underground storage tank, and its underground piping, especially the piping at the piping change their direction. It could be, and its congestion location could be the major leaking point. So trying to figure out this underground pipe, try to figure out this wet production process location, and it could be the most dangerous region of the soil from most dangerous sources of the soil and groundwater contaminations. And when you go to the site, you should try to identify the recognizable environmental conditions. Like this figure, I think it should be taken 2 years ago. So it's in wind process. You see the tank is you see the drum layer, and you see that of leaking from the drum, and the water in the or the solution in the drum spray out. It is one of the sample. One of the potential sampling point could be located here, and you can look your circumstance and to see the depth of the plants, and you can close to the water. This could be the one of the sources, or one of the impact area of the contamination. And sometimes the invisible leaking is from the underground. So you can see that this is a big hole here in the underground pipe, this black one. And when you open the surface and just figure out what happened here, and sometimes the building in between the buildings and their basement, there's some leaking point here, and the old brick built or a manhole should locate here. Some leaking point is at the bottom of the buildings. So this is the reason why we need to trying to close to the building, close to the sump, and trying to getting the sample close to certain depths at close the buildings and the wet treatment process, and trying to figure out the congestion lock point between the pipes. So general design of the soil sampling, and because considering about the object of the phase, your object, you can there's a different object you can design your sampling point. So I just give you a very quick idea about the soil sampling plan. So there's a lot of methods. One is random sampling point, and we did not use it because it is not easy to identify. If you are rich, you can do it, use a random table and taking the sample. And or most of us use the so-called judgmental sampling. So it is based on the phase 1 or OEC, it's a REC, recognized environmental characteristic, selecting and set up one sampling close to that site, and trying to figure out the potential impact area and the median you want to take, and set sample layer. For example, you are factory here, and you have a tank here, and you can set sample between the factory and the length, the storage tank, and trying to figure out what the distribution of the potential contaminations. And of course, you can use so-called systematic grid sampling. You set up a purpose size grid, and taking put a sample at the center of the point, and you can. It is a very simple, straightforward idea. So you just set up a grid and put a sample in the middle, and taking the sample back home and do the analysis. And sometimes if the factory cannot go in, you can move the sample point outside of the factory, so you can taking the sample here. So it depends on the design, and it depends on the restriction of the your sampling. And so when you want to go through the wind process, we spend a lot of time to discuss about the potential contamination area. So you can put your sample close to the lagoon, close to the warehouse here, and close to the west storage region from the aerial sample. It could be here, and at the water runoff stream layer or affected area. But after the fire, you should consider more. For example, you should taking the sample at the residual waste and the drums, and of course the runoff and the impact area, and remember the air pollution, because it's made totally different. And when the fighter goes in and they spray the water, so please taking a sample at different location, and maybe trying to figure out from the video and to see the smoke spray location, you should taking the sample. And don't forget, there's a 3D distribution, because the contamination won't stop there, especially the L nipple or D nipple. It will continue to go down and flow with the groundwater direction. So you should consider the 3D distribution of the contaminants. So when you touch the sampling plan, you want to take in a sample, you should considering the land use situation. for example, for farmland, most of the contaminant comes from the top surface. So the water goes in, so you can taking the 30 centimeter sampling and trying to figure out what happened here. But for the under storage tank area, you should taking the sample and at least under the bottom of this UST at least 1 meter and trying to figure out what happened. And if your budget is available, you can try to taking the sample, touch the groundwater surface. And of course, you should consider the distribution difference of the contaminant. For example, the heavy metal did not transport easily in the soil. So first 30 centimeter depth of the soil layer is important for when you're taking the heavy metal sampling. But for the L nipple or D nipple, you should consider the distribution of this contaminant. So you should taking the sample at the groundwater level variation location, or when you touch the D nipple, you should taking the sample above the first layer of the unsaturation zone. And for groundwater sampling, and I remember Professor Colin Chen mentioned at least you have to one groundwater point at the upstream and the 3 point of the at least the 3 point of the at the downstream and taking the sample. But for the L nipple or D nipple, you should considering the distribution of potential distribution of the groundwater. So if the sources here, you can set up a sample from at here and here, trying to figure out the distribution of the plume and trying to set up install the groundwater well as this kinds of line and trying to figure out what the whole distribution of the plume. And don't forget the 3D information. So you have to set up a different open the screen at different depths and trying to figure out the a potential distribution underground. So the object is very, very important. So different object can determine your sampling plane. So the wrong design of the soil sampling plane will only lead waste your time and money and collect the garbage data and give you a wrong picture of the CSM, and you can make the wrong decision. And the second point is your QA/QC. Your data quality object is to ensure the data collection that is good enough to answer your questions. So these elements you should consider when you doing the site investigation plan. So what is the contaminant you want to know, and you select a proper analytical method. What's the medium you want to take, and what is your sources. If you want to know the time or we say murders of the contaminants, you can select a different analytical method. And if you want to know the pathway of the transportation, you can you should considering different tools to getting the answers. And of course, if you want to doing the risk assessment, you should consider the acceptors samples. For example, you can, if you want to consider the biological toxicities, you may take tissues from the fish, from the pig, from the chicken, and to doing the more analysis. So basically, when you go to the wind process, now, for in the site, in the wind process, I suggest that you can doing the soil and groundwater sampling in the wind process. I believe the PCD and the groundwater department doing a lot of work, but you don't have the data information inside the wind process. So I just suggest you to doing the soil and groundwater sampling. So the key question is, where is the contaminant? What is it? And how deep is, and how wide of its distribution, and how to what is the concentration? So trying to call different sampling like this, and you don't have to taking a lot of doing a lot of sampling. Just use the judgmental method, taking some samples at the proper location, proper depths. You can get a very good result of to identify the potential sources. And if you want to doing the remediation, you can use the grid method, because you has already know the contamination may be located here. You want to know the distribution, so you can use the grid sampling method and trying to figure out what happened there. And I suggest that you can consider in so-called high resolution site characterization. So taking more sample at the proper sample distance and the proper sample size, you can develop the very detailed information. I won't talk too much about the high resolution site characterization. So the most important issues is trying to figure out what is the distribution of the contamination. It's too fast, right? So like this, you should try to know this figure is from the US EPA. You should try to figure out what is your neighbor pool is located here. What happened? What is the geological composition of the surrounding area, in different depths and in different transect, and you can doing the remediation more precisely. For example, if you remove this the neighbor pool, I think you have solved maybe 80% of the problem of a site. And if you want to doing the risk assessment, you know it comes from the soil skin contact or the other method, a potential pathway. You should consider the taking the sample of the soil and from the skin, or from the water, and trying to figure out the pathway, exposure pathway, and use the survey to doing the sampling, or the ambient air you should consider. So it is important to select a proper sampling method and the sampling target, and you can doing the risk assessment. And sometimes if you want to doing the environmental forensics, you should select the proper analytical method and apply it. For example, if you want to identify which contaminant, which oil contaminant it is, so you can use the GC FID or GC mass, and to see the spectrum of the different from different oil, and trying to figure out what is the major oil. And of course, you can do further analysis and use the PCA component, PCA, and trying to identify the potential sources of the oil. For example, this is the characteristic of the oil in Taiwan. So this is from the Formosa. This two is from the CPC, Taiwan Petroleum Company, and you can figure out they have a very significant characteristic, and we can identify who is the polluter. And of course, you can use the isotope method to identify what is the sources of the from TCE from different factories. Okay, so now I'm talking about the health and the safety plan for the field work. First, the safety rule number 1, work and leave. If there any potential the hazard arise, please stop your work and leave the site immediately. And please set up your health and safety plan. It is important. It is not a document. Please remember this information in your mind and following the SOP. And trying to understand the site background and trying to familiar with the situation of the site and familiar with your sampling plan, following a procedure, and use the proper personal protective equipment with you, and it can protect you from the immediate hazard. And the most important thing, the other important thing, don't touch the soil and groundwater. Don't touch the hazard material directly. So it is important. Sometimes the people use your hand to touch the soil, and it is not a good habit. And for a safety plan, I suggest you should have in the first section, you should have a site description, and you have your sampling order and the route, and trying to figure out how to enter the site and go out to the site. And the second section are the potential hazards and the exposure pathway. For example, you may have chemical issues, the vapor inhalations, skin or eye contact or engagement and inhalations. And it's some physical potential hazard when you operate your drilling rig, and you may touch the electrical wire, and some electrical shock happens. So you have to you have to avoid these issues. And sometimes when you operate your drilling rigs, some smash happen. Your hand or your feet may injure. And sometimes when you go to the site, it can fall in the site. And mostly important, Thailand is a very high temperature country. So heat stress is also the other issues. And if the site is like in process, the surrounding areas have a lot of trees, you should consider in the insects and the snakes around layer. So, and then remember, select a proper location of the site as a safety zone. Set up it and set up the cold zone and the hot zone and the zone in between it. You can remove your PPE and wash your hand, wash your feet, your shoes, and back home safely. And select a proper protective equipment, and bring some simple fire extinguisher with you, and for emergency issues. And of course, you have a design of emergency response SOP. If any bad things happen, you can following the rule and trying to figure out the rescue method. And for the protection equipment, we have based on our knowledge, we have 4 different labels. And for the soil and groundwater sampling, basically it will be level D. So you wear glasses and with a glove, and wear the safety boots, and work close to protect you to touch the contaminant directly. And if you are you have to handling hazardous waste, you should wear proper treatment, proper PPE with you. And for the mask, sometimes I suggest, especially for the wind process, I suggest at least you should wear R95 mask, because there's may have some acid vapors and volatile vapor in the factories, in the warehouse. So please wear proper mask. It can protect you to breathe or engage the hazard gases into your lung. And wear proper gloves. Normally we use the nitrile gloves or latex gloves, and this one PVC gloves is okay, but it's expensive. Or when you handling the hazard material, please wear a heat acid-based resistant gloves. It's different. So select the proper gloves with you can protect you. And when you doing the sampling, sometimes please wear the work gloves outside the other gloves, and it can protect you from the other work safety issues. And please set up so we say the safety zone. For example, you have to set a cold zone for rest. Don't eat food, don't drink when you go into the site. Only eat and drink at the cold zone without any potential contamination with you. And in the warm zone, you can wear your PPE, and when you go into the site, you wear your PPE, then go into the hot zone. And in the hot zone, the sampling treatment station and the waste package station, you put all of the waste there, and if it is contains hazard material, you can collect it and transport it to the outside for the further treatment. And so it is important to set up these 3 different regions for you when you enter the site and or leave the site. And there's some issues, pictures we had happened in our company. So when this is basic from the electricity shock. So for example, in this picture in here, this is because our geopo touch underground electricity wire line, and it is 36,000 volt. It's super high. So you see the cashier in the head of the geopo rig was melted. It's very, very dangerous. And when we use the hollow stand auger to install a monitoring well, even we did not close to the wire line, but the hollow stand auger is much bigger, and it's rotated underground, so the wire line was be pulled out from their plastic pipe. So it's also caused a lot of very severe issues. So it is important when you doing the soil sample or groundwater sampling into the site in the factory. It is important to considering this issue. Select the proper sampling point. Sometimes keep certain distance from the underground pipeline. So basically, I give you a basic SOP for the underground utility. First, ask a build drawing of your underground pipeline or underground facilities, and trying to mark out when you doing the site assessment, going to the site, and before you doing the sampling, trying to mark out this pipeline or underground equipments. And of course, use the geophysical method like ground penetrate radar or other tool trying to figure out the distribution or layout of the underground pipeline. When you put the soil sampling point, maintain the safety distance from the underground pipeline. Although I suggest you trying to close to the leaking point, trying to close to the potential leaking location, but still you have to keep certain safety distance. And then before you do the soil sampling, you can use the trial drill by hand tools, and it can reduce the possibility of the electrical shock. So in my presentation, I suggest some information to you. So the first, trying to develop your site investigation plan based on the previous information, because phase 2 is to confirm or qualifying the potential risk of identified in phase 1. And the site investigation can be applied in whole life cycle of a site. So it is important to it is objective driven issues. So please trying to scope or object trying to scoping your object, and you can have a proper site investigation plan, and use the technology properly and know the technology you applied when you doing the site investigation. It is important. Know the limitation, and you will get a better understanding of your result. And always remember, safety first, safety first, safety first. I say it 3 times. Be careful when you go into the site and leave the site. You don't want to lose your life in the site, right? So at the final things, clear yourself before you leave a site. You don't want to bring the contaminant back home. Okay. So facing the wind process, just bring this information back to your home. What is your plan when you touch the wind process? So this is my presentation, and I think we have about 5 minutes for questions.
Anyone has a question for Binan Wang? He covers a wide range of materials.
Just want to ask some question, because it might be the question where many of the team in PCD has problem for like complicated site like this one. You talk a lot about like sampling location. That is usually what we are taught is for single source. Probably already seen potential source of contamination. That is quite simple to basically set up like a sampling plan, especially set up like a upstream, downstream well or soil. How about this kind of site, a complicated site? Are there any recommendation on like a sample? What should be like the best sampling strategy that will not break the bank? Because it's potentially has everything everywhere, every plume intercept each other, right? I
Yeah.
mean, this probably is a good example for you to recommend to us where what is like what kind of sampling plan that we should be doing. Yeah.
Okay. To my opinion, I suggest for me, it is a very complicated site, right? And maybe you just put any sample layer, you can get a result. And so first things, trying to identify I will separate the site into several different locations. For example, the warehouse and this it should be around here, the warehouse location, and from the aerial photos in the about 2014, right? It's a west storage area located here. So we'll separate based on the storage tank, based on the potential wastes. So I can separate this into this region and this region and this region. I remember here they store a lot of solvent and acid and base. So we separate into several regions and trying to then select most potential area, most potential leaking point, taking sample first. So you can only select 10 or 20 locations taking the sample and try to figure out, use some geophysics tools and trying to figure out the potential distribution inside and select the proper sampling point. And then you can use I think at least maybe 10 or 20 sampling point. You can get the very preliminary information of the distribution. And I based on the information from the doctor, sorry, from the groundwater department, that has already tell you have about 8 to 10 meter sandy layer, right? So and you have you know the bottom of this sandy layer. So at least you can taking yourself, if you want to know the distribution, whole distribution out of contaminants, you can take it, you know the sampling depth would be within 10 meters, right? So we separated the sampling location and trying to use the very preliminary information, like this area store a lot of solvent. You are focused on the VOC, TPH, or SVOC. So, and for the warehouse, they have a lot of ash things, right? So it's maybe contain a lot of heavy metals and sometimes maybe dioxin things. Yeah. So you can select the proper target, proper chemicals you want to know, and then design your sampling point and the sampling plan. And you use the smallest budget to describe the distribution of the contaminant. And of course, the lagoon, you have to taking the groundwater sample and trying to taking the sediment sample, but it is not easy because the lagoon is very, very deep. So if you cannot taking the groundwater sample, just taking the sample around the lagoon and trying to figure out if they have a layer of the surface layer, if contaminated or not, and you has already know the depth of the lagoon, and you can taking the sample near the lagoon and trying to install trying to taking the sample maybe 5 meter or 6 meter. You can know the potential leaking, potential exchange of the lagoon and to the surrounding groundwaters. So there's a lot of method, and there's more give you a more flexibility and a more imagination based on the CSM, and you can get a preliminary, more use the smallest budget and to get the preliminary distribution of the contaminant. Yeah. So this is my opinion. So maybe Dr. Huang.
I just want to say it depends on the available resources, but I think that sometimes there's a so-called responsive clustering method. The reason I recommend that is because of basically it's a grading method. But usually we can imagine that I pick up one of the grid to do it, but I will assemble, say, 9 or 16 grid into one block. And so in the whole, for size at this size, actually we can first pick up the first point for each 16 cluster based on our phase 1 investigation. So we interpret the phase 1, and I found out, just like Binan said, that maybe the lagoon or the pond, but or inside the site. So we have 16 block into 16 cluster into one box, and I using the phase 1 information, I pick one of the spot to do the sampling, and I define a really high concentration from that. I have 16 block, and I will move from one block to one direction to see which direction is what I want, and then go by that. So kind of dynamic sampling. That might be able to give you some and save you some money and give you better resolution. Also, that one thing you can consider, actually, we also mentioned about the high resolution site characterization. Instead of really sending the sample to the lab, maybe we can try, say, I want to understand what's the content or concentration of the heavy metal or something like that. Then we just use the XRF to scan through the site or scan through the cluster, and you find a better resolution. After that, then you can pick the sampling point. That also can save you some money. So there are many ways to do it, but still it has come back to the resources and something like that. But for the size of this, this size, this kind of mega site, well, I used to use the clustering, responsive clustering, so you can kind of move around. Yeah.
Can I? Mr. Wang, thank you for your presentation. I just like a quick question. Can you give us some examples about, like you said, like new chemical formed with high temperature and reaction, for your opinion from these wind process cases?
I'm not pretty sure, but maybe for example, you must have the experience when you clean up your toilet, you use the HCl, right? And sometimes you have different kind of detergent, and you mix it together, it will cause the heat, the smoke, right? So we don't know, when you go into this site, you have a lot of solvent, you have a base, you have acid. If they are mixed together, so it's the sources of the heat, and the maybe toxic acid forms something. So it is truly dangerous. Yeah, because this site, of course, it's burned. I'm not pretty sure, but everything is mixed together now. So it's the other issue you should consider.
I think Binan Wang has prepared a lot of material. He also covered the safety, health and safety issue for phase 2 investigation. According to our material, Mitch also has material for health and safety for a phase 2 investigation. So I suggest we just skip that section and move to the next topic, because I don't want all of you feel bored to repeat this topic, So if you agreed, will move to the next topic, which is about Dr. Mongdefang will talk about hazardous waste management. Yeah, Mitchell has a section, a video about health and safety. So I think I believe Binan covers most of it. Yeah, the video was about 35 minutes and also covers 2 practice exercises. So I think we can move to the next topic and focus our energy to the other section.
So, good afternoon, everyone. It's my pleasure to be here. My name is Dr. Mongdefang. I'm from ITRI, this Industrial Technology Research Institute. Yeah. Sorry. Yeah, from his laptop. Okay. I will cover in today's slide. I will cover the structured framework for industry waste management and examine the challenges posed by illegal dumping, and also review the reference operating procedures for cleaning up these sites, and also conclude with a specific case study. Okay, I have to change my slide in head. Okay, before I dive into the core topic, let me briefly introduce ITRI. ITRI was founded in 1973. It's partly funded like 50% by Taiwan government. We have more than 6,500 employees. Our core mission is to driven industry development and create economic value and enhance social well-being through technology R&D. So I think the company TSMC, you might know it, is from our institute. Yeah, and ITRI's research and okay. ITRI's research and service area cover a broad range, including biomedical technology and the information and communications, and also the area I represent is green energy and environment. For the last 30 years, we have cooperated with Taiwan government to clean up sites like this one is in Pingtung Xinpi site, which was the largest waste in drum dumping site, involving more than 6,000 drums of hazardous waste and heavy metal sludge, and also contaminated soil. And other than other major cases include this one is a Kaohsiung Tamping site. We have cleaned up this site for more than 200,000 cubic meter, and also hazardous waste about 70,000 tons. And for this site, our government spent more than 1 billion NT dollars, which is similar to Thai baht. And the small bit you can see here, and also you can see a lot on the left, down the left picture. It's the granular fly ash in the steel mill. So it's a lot. That's contain a lot of heavy metal and also some dioxins. And we also have a site in, wow, it's quite slow. Okay, we also have the other side, it's Tainan Urban River. Okay, it's we have cleaned up these sites for about 174,000 cubic meter, and also the hazardous waste is almost 82,000 tons. And the waste in this site is from, you can see that it's PCB board from electric waste, and also some acid sludge from treating the PCB board or waste cable. There are also dioxin contaminated soil from open burning of the waste cable and in these sites. I know Thailand is now trying to build up an environmental cleanup fund. And there is an idea for your information to assess how much sites you can clean up during the early stage of your fund. If you don't have enough money for every site, you might have better to rank all the sites and to decide which one to start first. For the past 30 years, we have in Italy, we have helped Taiwan government deal with 425,000 tons of hazardous waste and 12.4 thousand drums. And we have spent $4 billion, more than $4 billion, and that's for only 7 sites. Okay, and we have more than 153 sites in Taiwan. Okay, I will talk about it later. Yeah. So it's almost the same. Yeah. And next is let's now turn to industry waste management framework in Taiwan. The framework governs the life cycle of industry waste, and before operation, before operation, and also during the operation and the close. And before the operation, thank you. Before operation, okay, no. The industry have to appoint a waste professional and technical personnel, and they will to try to create the industrial waste disposal plan for inspection. And this waste disposal plan is very important, which can design all the your waste are going to deal with. You want to treat how to deposit, how to storage, how to treat it, or you want to reuse it, and you have to follow strictly to this disposal to do your industry waste, and crucially, the enterprise must determine the waste code, and which are the plan and set up in industry waste treatment facilities to ensure proper storage and report the flow paths and keep records. When your enterprise is going to close, might be relocated, or might be ceased, or declare bankruptcy, the disposal of your industry waste must be handled strictly according to your approved disposal plan. For the disposal and reuse of industry waste in Taiwan, the frameworks you have the industry waste can be handled through you can the industry can do it by themselves, or they have to do it by entrusting waste removal and disposal companies. I mean, the do it by themselves is recycling within the factory, or you can if you have an incinerator in your factory, you can burn it off. It's also permitted in Taiwan, but you have to get the permission first. And for reuse, there are different channels. Like for recycling within the factory, for all the in-house processing, this is reviewed by the local government, and the plan have to be reviewed by Air, Water, and Waste Management Authority. And for offsite reuse, the waste required permission to be reused, and this requires review by the local government and or by the national government. The competent authority or the target industry also play a role. They can decide which they have the power to permit you can do the offsite reuse or not. And for waste disposal, the disposal facility and the processing license are managed by the local government. And for the monitor, for this management, when you are shipping the waste between the factory or between the industry and removal company, you have to the industry waste must be monitored and tracked. A critical component of this framework is tracking the waste flow path. The EPA Industry Waste Declaration Management System collects our national waste declaration data and monitors the waste flow path. And for the local governments, they will track the waste flow path within their jurisdiction and conduct inspections and penalties. And reuse companies must also monitor product use and the flow path. Everything have to need to be recorded and keep in the system. And despite the regulations, illegal dumping is still a significant challenge in our country. We have identified over 153 sites across Taiwan in that's data in 2011, and the dumping locations are highly diverse. We found many. Why we keep this different kind of dumping behavior is because if you want to prevent the illegal dumping site, you have to know what kind of behavior they will dump. Okay, so this site this behavior is can be divided by a different type. For this kind type of dumping is for the valleys. This place is near. I remember it's near Hsinchu. It's in the here slide. They dump a lot of construction waste and also some garbage. And also there's some dumping dump area in the riverside. This is in the middle Taiwan. It's called Wuxi. And this side, what are dumped with, you can see the familiar, we just saw the photograph. That's a granular fly ash. So the picture on your left side is during the fly tide. You know, the water will cover this this waste. And during the low tide, the waste will comes out. And also we have a dumping site like this is a roadside dumping, and the behavior is very easy. You can, if you see the left hand picture, they usually they load the drums in the truck, and during midnight they will drive to nobody see a place, the roadside, and then kick out of the drum or push down the drum. So you can see it get in line here, right? Yeah. So it's very typical roadside dumping, and also, and very typical. And also you can see, I remember in the right hand side, the down picture, there's two gray tanks. It's a tank full with oil, and inside is sodium. So it's very dangerous metal. Sodium. Yeah. So that's kind of if you don't know what's inside and the oil is drained out, the sodium will comes out, and it touch the air will burns out. So that's very dangerous. And also we have some dumping from that's ponds in northern Taiwan. That's in Taoyuan. You can see there's a lot of construction waste. In the ponds. And also we have a dumping in the factory. Okay. So there's a couple different kind of factory dumping. One is when the industry is bankruptcy, they just go away. Leave a lot of waste in on the site. And also there's another type of dumping. They rent empty warehouse and take money from the big company and receive their waste, then ship to this warehouse and then go away. Just go run away. So it's the same here, right? It fits everywhere, all the world. So we do a lot of this kind of work in Taiwan because when the courthouse they try to deal with this kind of drum waste, they will call us to do this to see what kind of this waste it is. Okay. So so in the talk yesterday, I saw that a dumping site inventory is proposed to do in Thailand, right? And that's good because you will need those data to identify the type of dumping behavior and further ranking those sites to use limited resources to cover the most sites. So I will introduce a little bit about how we ranking the sites to decide which site in Taiwan have to deal with to clean up first, and the other side to clean up afterward. In Taiwan, we classify our illegal dumping sites into 4 different kinds of classes, A, B, C, D. And the severe and requiring a hazardous rating score greater than 28.5. It's according to your pollution sources and also your exposure pathway score. It's US HRS.
US EPA program exactly?
Almost the same. But the number is and then we will decide and also for the class A, the sites are have some specific requirement. You can see that in the left-hand side. And if the civilian groundwater wells are contaminated, or air is contaminated by organic vapor, or the hazardous waste has a high exposure risk to neighboring receptors, so that would be classed into Class A. And also there's some way to classify the different kind of the site. And okay, for now I'm moving to the reference procedures for cleaning up the illegal dumping waste on government-owned lands. Okay, so we have these reference procedures. This reference procedures is set up by my colleague in my group. Okay, we work with our government to set up these reference procedures. And I also, from yesterday talk, I know PCD has built a 7-step framework for contaminated site management under your guidance. Okay, I think I have looked at the 7 steps and compare with our 6th step. It's kind of a little bit different. Okay, US emphasized on how to remediate contaminated sites. Okay, in Taiwan, we will specifically point out the responsibility for the landowner and the authority. They have separate works to do on the 6 steps, and we have to identify what they have to do. If you are a land management agency and you follow this 6 step to do what you have to done, and your liability will be lower. If you don't, after the courthouse might have some liability on you. Okay. And to systematically manage these sites, especially those on government-owned lands, we follow this 6th step, and this is for the step 1. It's also almost the same to your steps, and we have to do the site discovery, and we have a management system. So you have to the EPB or the Minister of Environment will register the site on our system. So the process begins with the land management agency. They will have to confirm the scope and investigate any agriculture or aquaculture activities. If they have a farm or they have fishing pond, you have the land management agency have to report to EPB, and we will find the EPB will, or the Minister of Environment will find the Minister of Agriculture to come to this group to know how to deal with the following procedure. And also the EPB and Minister of Environment, they will conduct on-site surveys and to see the surrounding land use investigation, and also soil and groundwater testing. They then register the site in the illegal dump disposal site reporting system. And the immediate emergency isolation is required. And we will install in warning signs and using fences for isolation, and increasing the environmental patrols, and implementing necessary barrier measures according to the waste type. If water is contaminated, the land management agency, they have to provide the potable water to nearby residents. And for the step 2 is try to clarify the cleanup responsibility. The primary goal of this step is to identify the direct polluter. The land management agencies and the local governments and Minister of Environment assist in the investigation and evidence collection. Tools used including reviewing the investigation and evidence collection, and tools used include reviewing the historical area photographs and on-site evidence, and also surveillance footage, and some if there's a GPS track, we also analyze the GPS track. For your information, in Taiwan, the truck, when you are shipping the industry waste, you have to install the GPS track system. And if a responsible party is identified, follow the Waste Disposal Act, we will take the action and ordering them to clear and dispose of the waste within the specified period. And if there's no this one, if the actual responsible party cannot be identified, the local competent authority may order the land management agency to conduct the cleanup. And for the step 3 is the site investigation. The land management agency, they will investigate the waste characteristics, distribution range, quantity, and hazardous properties. Based on the analysis, a professional technical team is consulted to select appropriate removal, treatment, or reuse methods. Because the land management agency, they have no this kind of professional skill. And for the EPB or the Ministry of Environment will assist in identifying the waste characteristics and offering consultation. For the step 4 is the cleanup plan development. The then management agency, they will commission a professional technical team to draft the waste dumping site cleanup plan. This plan is submitted to the local government for review and approval. Once approved, a control number is issued, and the EPB or the Ministry of Environment, they have to review and approve this plan, and they also accept applications and issuing the control number. And for the step 5 is the execution of cleanup operation. And the land management agency, they will execute the waste clearance and disposal and recycling work in accordance with the approved plan. They use a real-time tracking system and report the status of waste generation, storage, and disposal online to Ministry of Environment. And the EPB and the Ministry of Environment is very easy. They just supervise the works. And for the sixth step, step 6, it's about the environmental restoration and delisting. And that's finally the land management agency, they will submit the results to EPB to apply for delisting. And the local government personnel, they must confirm on site, and or if these sites are all cleaned up and the treatment and recycling have been completed according to the approved plan before the site can be delisted. And after the cleanup operation are completed, and soil and groundwater testing must be conducted. And delisting can only occur after confirming the environmental safety, and a long-term management mechanism must be established to prevent the further illegal dumping. And the easy way is to use the fence to surrounding the site. Okay, that's the most common use for the land management agency. It's still a little bit slow. Okay. Oh, and now we move to the case study in the Mount Hongsha site in Kaohsiung. Oh yes, government sector, and for the private owner, the land owner, we have the other procedure for them. Okay, it's almost the same, but we will because for the government sector, it's easier to ask them to do the things, but for the private, it's more legal stuff will coming in. So for the case study, okay, this site is because the illegal cleaning companies, they took money from the company from the industry and accept their illegal their industry waste and then dump in this this area. The people around here, they petitioned to a legislator, and they found a lot of drum waste in this area. During that time, we found the phenols, the total phenols in groundwater is 2.03 milligram per liter, and our groundwater standard is 0.03 milligram per liter. So it's almost 100 times higher. So and after preliminary investigation, we identified this site as a Class A site by Ministry of Environment in 2000. And the cleanup started from 2004 to 2009. And this site is very large. It divided into Area 1 and Area 2. For, I'm sorry, it's wrong. For Area 1, it's coming back. Okay, for the Area 1, it contained 3,000 drums. Area 1 is the lower place in the slide. That's in the south. No, don't touch it. Okay, you will keep jumping into these two slides. Sorry. And Area 1 contains 3,000 drums and also 1,500 tons of heavy metal waste. And the Area 2 contained 500 drums. The drum waste was highly hazardous. They contain substances like benzene, taurine, xylene, styrene, creosote, and phenols. It's total phenol. And the cleanup process is before. Sorry, we have to jump to the next slide. So don't. Okay, that will be. Before we clean up, we have some legal process, specifically the subrogation were required because the land was owned by 24 different individuals. This place is private lands, and the overall cleanup strategy targeted a total volume of 70,000 cubic meter of contaminated materials. The private priorities were the 3,500 drums and the 1,500 tons of Okay, good. Sorry. 1,500 tons of heavy metal hazardous waste. And we also have a lot of so-called general industry waste. It includes slag and sandblasting residue and construction waste and also combustible industry waste. So for this site clean up process, we start by clean up preparation, and then we start to excavation and sorting and repacking. Why we have two excavation is because you will see later for those drum waste, about 500 drums were empty because the waste inside are all spilled out. So they contaminate the soil and also the groundwater. And we for the combustible waste and heavy metal waste, and also for the general industry waste, we have different kind of test and also removing and screening method, and also move to the disposal company. And during this process, we have to verify if it was disposed properly, and if not, we have to send back to the intermediate disposal, and then to the final disposal again. So it's very strictly to see every step. We want to make sure all the waste was shipping out, and all the waste are shipping to the right place and preserve very carefully to prevent this waste coming out again. So let's go to the next slide. Okay. Okay. So as you can see, oops, sorry. Okay. As you can see, the drum in the okay, in the left side upper picture, the drum was stacked in. It's not lined up because the trunk packing the drums, and then they will give up the trunk, and all the drums just coming into the hole, and it's very easy to break or spill the container. Okay, so we have to remove the drums, and then to do the inspection from the outside to see if the drum is okay, and if and also sorting the empty drum and with full drum, and then we have to decapping, open the drum, and to see what's inside, or if for this decapping drum is because we also have to repacking, so we have to open decapping it. Okay. Okay. The screening results for the drum waste were highly instructive. We found the waste in these drums contains flammable waste about 41%, and also others is 56%. There's waste dye and also waste resin and some reactive waste is about 2% and corrosive is 1%. And so, and the drums, every drums have to be coated and from the ore and repack, okay, from the ore drum to put into the new drum and repack the repack drum. Then we take a sample. We have to sample in each drums. This is not to trace their source. We have to, that's for treatment or disposal afterward. Okay, you have to know what's inside the drum. Oh, so yeah. Okay. So after the screening, we found liquid is 300 drums, and solid is 1100, and empty is 500 drums. Okay. You can see there's a lot of waste resin, waste dye, and also some laboratory waste. And for the flammable, oh, okay, yeah, it's still going. Oh, yeah, for the contaminated soil, that's a total 502 spilled empty drums, and we pack 130 bags of contaminated soil. One bag is about 1 cubic meter. That's for the area of 502 spilled empty drums. For the okay, then for the process of heavy metal hazardous waste, we require. Well, it's still going. Oops. Oh, okay. I'm sorry. It's still jumping. Okay. For the heavy metal hazardous waste, we requires a specialized process. We will utilize the SRF for sorting. Okay. This is how we process the heavy metal hazardous waste. And after we pack in the contaminated soil, we will ship into the company, and they will use concrete to mix with the contaminated soil to become a concrete solid. And we have to coating every bag of the concrete, and then locating every place for this what is jumping? And if for the concrete, and if and also we have to I just mentioned we have to do the verification. So we will take sample from the concrete to see if they will reach the hazardous waste. If they do reach the hazardous waste, this concrete have to remove and to do the same thing again. Okay, so that's to make sure the final disposal is well established. Okay, so still jumping. All right. So 我是到3:20嘛 ，OK. Oh, the good news is that's almost the last slide. Yeah. So oops. Oh, there's also some general industry waste. We are sorting and classifying the by the result of XRF That's okay. That's okay. That's just the next slide. Yeah. We also that's a slag and sandblasting residue and some construction waste and combustible industrial waste. And also the sludge, waste cable, sheaths, scrap metal, and waste plastic. Okay. Before the end, I think for Taiwan, we are now moving to preventing the illegal dumping. You know, the best way to deal with the illegal dumping is try to to do something to prevent. Better than you spend a lot of money to deal with to clean up. Why is jumping? Okay, so the way we do is we work. You know, for the waste for the illegal dumping, they have a supply chain. Okay, they have source, they have shipping, and they and also the final disposal area. Okay, so for the source, we the way we do, we try to recognize from the drums or from the waste to see if there's any evidence from the large company. Okay, for large company, they will they values their reputation and fear the regulatory penalties, because if you do this kind of things, the one have to go to the prison will be the CEO of the company. Yes, yes. So they will do this very careful. If they are, if they know someone has been get this punishment or the penalty, yeah. No, you have to go to jail. Even have a, if you make some people dies, maybe you have a death penalty. So it's very dangerous, very serious.
But there's a criminal. Yeah, that's a criminal.
Yeah, that's criminal. Yeah, yeah, it's criminal. Yeah, and also for the shipment, we now our group is helping the our government to develop technology for hazard prediction by AI. We try to collect. We have very experience, okay? So we collect a road track for trunk and the location of industry and the location of the treatment plant and all the historical sites, etc., the data, and all collected and computed by AI, we can see the hazard, where might be the most place to monitor. So we can set a civilian video over the hazard. They will save a lot of money. If you want to install the civilian camera, CCTV in every road, that costs a lot of money. But if you have a hazard, we will follow every road lead to the hazard. Okay, that will save a lot of money. And that's our funding is from the government. Yes, we help them to develop this technology. Yeah, and also we also will surveillance to monitor for the abnormal GPS track. You know, if the trunk they report they would go from A to B, and they only two a row from A to B, and this trunk come from A, then disappear in the middle of somewhere, then suddenly appear in the B. There will be a problem, and we have also have some software to identify this kind of behavior, and then they will alarm our platform to know to see that there's some problem in that area. And also for the disposal company, we strictly monitor amount entering the company. You have to do the mass balance. If there's something missing, must be investigate to audit it, the company. And I have some take-home message for the industry waste. If you come from the company directly, it's a well-known characteristic eligible to be disposed and reused. But for the illegal dumping sites, the industry waste is very is unknown and it's all mixed up. You will never know what's inside. So the reuse and the disposal is very difficult. So before you do that, you have to sorting and I said isolating. Okay. So and also disposal of industrial waste must be monitored and well managed, or it will come out again. Okay, that would be quite similar in Taiwan. And when as Dr. Wang have mentioned about in his talk, inspecting the illegal dumping sites must be handled with caution. You never know what will come out. Here is a small video. I will show you. That's a drum. You see the drum is popping out. Yeah, that's because of high pressure inside the drum. So that's my colleague. He's open it very careful. He told me when he see the drum pop out, he's very, very concerned. Yeah. And there's no sound. You can hear it's very quiet place. And you can also hear the burn chimney. And yeah, it's a little bit. Oh, it's still.
The slow motion is good. So
yeah, it's very small. Yeah, it comes out, and all the people around here are just astonished. Oops. Okay. Thank you for your attention, and once again, you can have some question we can discuss later, or I have an email on the screen. If you have some question, you can send me an email. I would very willing to share to exchange the opinions. Thank you.
มีคำถามเพิ่มเติมไหมครับถ้าทางมีแต่คนเห็นรูปอะไรคล้ายๆกับของเมืองไทยเลย Okay, we don't have any further questions, so we're gonna have like a 10-minute break for refreshment and restroom. So we come back at 25. Yeah, thank you.
Okay, welcome back. Hope everyone's doing well. In the Trilateral Partnership October 2025 workshop focused on contaminated site management, capacity building, and especially short-term actions that can be taken to increase stability, increase security, reduce exposure, also known as removal actions. Hope you're having a good experience so far. And this is day 2 of the workshop. I'm recording this on October 22nd, 2025 in Philadelphia, Pennsylvania. And you are looking at this next week, next Tuesday, before you mobilize to win process on Wednesday. So, 2 things going on. You know, the purpose of this pre-recorded session is to talk about the site inspection of the wind process facility And I have kind of two pieces to this pre-recorded session. And piece number one is I want to talk about what I'd like investigation teams to do while on the wind process site. And piece two pertains to, because my kind of focus is on removal site evaluations. Evaluations of threat, evaluations of existing information, evaluations of current site conditions, and using common sense above all, but also using the conceptual tools like the conceptual site model checklist. I'm seeking to identify clear problems with stability, security, and exposure. And at the end of this workshop, I'm hopeful we can have a discussion to identify, what are the biggest threats that remain at wind process as an example site that could be mitigated with short-term, relatively low-cost actions. That's the goal of this thing. So the first piece of this pre-recorded presentation is focused on the things that I like to focus on, which is removal site evaluation, stability, security, exposure. The second piece of this pre-recorded session is a group discussion facilitated by workshop leaders, either from TPCD, the Thailand Pollution Control Department, or from the Taiwan Ministry of the Environment. And the goal of that group discussion will be, how can we use the activities that we have planned tomorrow, which is Wednesday, the Wednesday of the workshop. We have plans to do soil screening, soil sampling, surface water sampling. How can those activities be coordinated with the removal site evaluation activities that I'll talk about right now to improve the conceptual site model and to identify exposure problems on the wind process site and near the wind process site? So the first piece of this is my proposal for what a site inspection would look like, how it would be performed, what the goals would be. And the second piece of this is a group discussion to talk about certain activities being led by the Taiwan Ministry of the Environment and how those surface water and soil sampling and screening activities can be incorporated into the conceptual site model and can be used to better define where we have exposure problems on the wind process site and near the wind process site. So when I thought about the site, I have a stack of articles on wind process. It's maybe a 1/4 inch thick. I've read through them multiple times and thought about them, thought about the site, thought about what I observed when I was at wind process before the fire, thought about, that was in 2023, thought about what I read about the fire in 2024, and thought about, how could wind process be used as an example site in 2025 to demonstrate removal site evaluation and evaluations for stability, security, and exposure. And what I've kind of thought about and what I'm proposing is what follows on this slide and the next couple slides. For the removal site evaluation, which is described on the agenda as phase 1 activities, there's not a ton of time. But what I would propose is we assemble at least 4 teams. I was proposing 6 teams originally, but I had a great conversation last night that would have been, for me, the night of the 21st with Dr. Hung, Dr. Huang, and Dr. Cheui. And it seems like 4 groups will be more likely for this site inspection as opposed to the 6 groups. And I guess we could divide people up into 6 groups if we needed to, but there'll be 4 basic groups for the removal site evaluation. Group number 1 is going to focus on evaluation of sources in the burned and non-burned site building. So group number 1 can be a decent sized group of Thailand regulatory personnel plus Taiwan Ministry of the Environment advisors. And that group is going to perform an inspection of the wind process buildings. Naturally, at the very beginning of this activity tomorrow, there'll be the health and safety plan, the one-pager, where we identified what we believe to be the main health and safety hazards at wind process, where we'll discuss what kind of steps can be taken to mitigate those hazards, and we'll talk about contingency planning if something were to go wrong from a health perspective with a member of our team. But the first group, I want to focus on the wind process site itself. What remains in terms of sources on the site? What remains within burned buildings, within unburned buildings, and outside of buildings? What kind of sources still remain? And I would propose, using the conceptual site model checklist, each of these groups, each of these investigation groups will use the conceptual site model checklist as well as their common sense, as well as other tools that they may have used for similar investigations in the past. To primarily, we're gathering information to update the conceptual site model and to identify problems with security, stability, and exposure. We'll talk about that in a second. But the first group, I would propose inspecting in a safe manner the remaining buildings on site, burned and unburned, for the presence of sources. Sources inside the burned buildings, sources inside the unburned buildings, and sources on the wind process factory outside the buildings. Group 2, I would propose, focuses on the lagoons. There's a number of lagoons on the site. And once again, it's a source evaluation. This, group number 2 might be augmented by personnel who have experience with basic civil engineering, basic geotechnical engineering, because I'd like to see an evaluation performed of the berms of those lagoons. Are the berms still competent? Are they showing signs of decay? Are they showing signs of failure? Is failure a possibility in the near term or not? How do they look to A, from a common sense perspective, and B, from the perspective of a competent professional with some background in civil engineering or geotechnical engineering? That's like wish list kind of stuff. So group 2 would be inspecting the lagoons. Once again, as a source evaluation. Are there problems with stability? Is the primary thing we're looking at there. Group number 3 is the security team. The security team, what I envisioned was the security team would analyze the boundary of wind process and would analyze what areas are secure, what areas are insecure, and make an overall conclusion on the security of the site, the ability of fences, gates, alarms if they exist, etc., to keep trespassers off of the wind process facility. So group 3 is the security team. And a common sense, we're not police officers, we're not soldiers, but we have common sense. We've seen contaminated sites many times throughout our life. We're a highly evolved organism with good common sense. What does security look like to the security team? They're analyzing the site for security problems. And the fourth group, I proposed having a small team analyze off factory areas off the wind process site for exposure problems. And I primarily thought they would analyze soil and soil and surface water off of the wind process facility. All this can be adjusted, based upon conversation, discussion amongst the group. But these are the four basic types of teams that, as an example site, I wanted to propose inspecting wind process with these 4 types of teams: source areas in buildings, source areas outside of buildings, source areas in burned buildings and unburned buildings. 2, lagoons, 3, security, and 4, soil and surface water down gradient downstream from the wind process site. Sliding myself around here so I can see. What I'd imagine originally was 6 separate teams, but 4 separate teams will be adequate, as I've mentioned. 1 for buildings, 1 for lagoons, 1 for security, and 1 for impacted media off-site. And the way I imagine the teams kind of being organized is each team should have some form of a team leader, you know, someone to sort of like act as an overall leader for each investigative team. Each team should have a data recorder, you know, someone whose role is to record the data that the team collects while inspecting their part of the site. I wanted one team member to be a health and safety observer, a person who's, you know, read that 1-page health and safety plan, participated in the tailgate briefing at the beginning of the day, and can be the overall person to ensure that the health and safety ideas to mitigate health and safety hazards are complied with. And of course, with each team, I wanted there to be a Taiwan Ministry of the Environment advisor to provide feedback, to provide assistance, to provide their professional views during this inspection of the wind process site. So each team, I think, would at least include a team leader, a data recorder, a health and safety observer, as well as a Taiwan Ministry of the Environment advisor. Naturally, the teams, as they're analyzing the site for sources, they're analyzing the site for impacted media, they're evaluating the site for stability problems, security problems, and exposure problems. They're really using, they're not looking through magical glasses and finding things out that a normal person wouldn't see. But they're trying to use their common sense and their best professional judgment to reach conclusions. I think that, you know, our own mind, the human brain, is probably the best tool we have as we're trying to investigate a site, make observations, reach conclusions on stability, security, and exposure, and then ultimately propose a path forward. Maybe not to totally fix the site, but to improve the site, to improve the site's stability, security, and exposure. So for these teams investigating the site, what I wanted them to do, depending upon their role, either buildings, lagoons, security, or impacted media off-site, for folks dealing with source materials, you know, I wanted them to record information like approximately how much source material remains. Is it a waste pile? Is it a pile of burned containers? Is it a pile of unburned containers? Is it a remaining pile of smelting dust, something like that? So some estimate of the quantity of the material that remains. Some information on, is the source material containerized or is it uncontainerized? Is it within a drum or a tank, or is it in a pile on the ground? Does the source material lie on an impermeable concrete floor, or is it lying on the bare earth? Is the source material inside of a building with a competent roof? Is it exposed to the rain, basically? Or is the roof still in place, keeping the rain off the source material? And we kind of know how this works. I mean, you know, source material out of a container, exposed to the rain day after day, week after week, month after month, that's an ongoing source of contamination into the environment. That's different than a source material that's containerized or within a secure building with a competent roof. Common sense stuff. What we're trying to do here is ascertain what is the biggest problem right now. What is the thing that we could do now to improve stability, improve security, and reduce exposure? And finally, I mentioned, you know, I would encourage the investigative teams to use the CSM checklist to identify stability problems, to identify security problems. for folks that are more focused on impacted media, especially off the wind process property, I proposed, making observations to the extent they're knowable on the aerial extent of soil and groundwater contamination adjacent to the facility. Maybe we don't have time. I think the time slot is like an hour. Maybe there's not time for a comprehensive analysis of all the areas around wind process, but maybe there's time to focus on a specific area or a couple specific areas. So with regard to impacted media, I wanted the investigative teams to focus on the aerial extent, if it can be known, of soil contamination and surface water contamination. We're in the removal site evaluation phase of this thing. We're trying to use our mind, our eyes and our mind, to ascertain the presence of contamination. Those are not the only tools we have. We'll talk about phase 2 activities involving sampling and screening next. But for the removal site evaluation, I wanted the teams to observe physical characteristics, discoloration of soil, impacts to vegetation, different physical characteristics, physical states that could be, from which we could infer the presence of contamination. Maybe even try and tap into local knowledge. For folks that are performing evaluations of impacted media off the wind process site, is it possible to speak with local residents while you're there, although for a very short period of time, to find out what they know about the extent of soil and surface water contamination? Obviously, we're using wind process as an example. All this may have already been done, but what we're trying to do here is practice a process to perform removal site evaluation and to reach conclusions on security, stability, and exposure. And finally, for folks analyzing impacted media, I also wanted them to use, the CSM checklist as one tool, plus other tools that you may have used in the past when you're analyzing contaminated sites. The CSM checklist, when I put it together, the idea was to find a simple tool to identify not the total extent of contamination, physical characteristics, discoloration of soil, impacts to vegetation, different physical characteristics, physical states that could be, from which we could infer the presence of contamination. Maybe even try and tap into local knowledge. For folks that are performing evaluations of impacted media off the wind process site, is it possible to speak with local residents while you're there, although for a very short period of time, to find out what they know about the extent of soil and surface water contamination? Obviously, we're using wind process as an example. All this may have already been done, but what we're trying to do here is practice a process to perform removal site evaluation and to reach conclusions on security, stability, and exposure. And finally, for folks analyzing impacted media, I also wanted them to use, the CSM checklist as one tool, plus other tools that you may have used in the past when you're analyzing contaminated sites. The CSM checklist, when I put it together, the idea was to find a simple tool to identify not the total extent of contamination, but to identify threats, stability problems, security problems, and exposure problems. And for now, focus the resources on them. I got this, like I've said before, I know I used to call it a moniker. That was not the right English word to use. I think it's a maxim, but it's ATO, always think objective. What are we trying to accomplish by visiting wind process, by performing these inspections? Well, above all, we're trying to collect data. We're trying to collect new information to update our conceptual site models. You know, we have a conceptual site model that was constructed based upon existing information in our minds and existing information from presentations during the workshop. We want to update that conceptual site model, maybe just a little bit, but we want to update that conceptual site model based upon new information that we'll glean from this site inspection. Using the conceptual site model checklist, using our own common sense, we're seeking to document evident stability, security, and exposure problems at the site. We're trying to prioritize what is the biggest problem, a small number, and what are the main problems, either stability, security, or exposure, present at the wind process site today. I make a note on the slide, it may be impossible to completely remediate wind process in the near term, or maybe ever. You may never be able to restore wind process to a pre-contamination condition. That's an opinion. That's an opinion based upon my own experiences in contaminated site management. But the question I'm posing to you is, can we reduce exposure? Can we increase security? Can we increase stability to reduce the threats posed by the site? And we will talk about removal action selection during the very last presentation, the very last US EPA pre-recorded presentation, which is the next one. Oops, sorry. So that was my pitch on a suggested approach to the phase 1 activities at the wind process site. And of course, I'm very grateful to the Thailand Pollution Control Department regulatory personnel who can improve upon the plans that I had, and also to the Taiwan Ministry of the Environment personnel, certainly the advisors who have come to Thailand. Hopefully, perhaps they can also improve upon the plans that I had. But that was my plan for the removal site evaluation, focused on stability, security, exposure. As a group activity, as part of this pre-recorded US EPA session, I propose a group discussion. And the topic of that group discussion that we're going to do right now is, how could soil sampling and screening? There's kind of two pieces to the wind process site visit. There's the phase 1 piece that we've already discussed. We've talked about that in this presentation. But there's also some sessions for soil sampling, soil screening, and surface water sampling. And what I'd like to do right now within this US EPA pre-recorded session is I would propose a group discussion led by a workshop leader, led by Thailand Pollution Control Department or Taiwan Ministry of the Environment, a leader of this workshop. How can the phase 2 activities, how can the soil sampling activities, how can the soil screening activities, how can the surface water sampling activities be performed and focused at wind process to accomplish two goals: to improve our conceptual site model and to evaluate for exposure problems? How can these activities be performed in an intentional way to augment the removal site evaluation? How can soil sampling, soil screening, and surface water sampling be performed to further elucidate, to further clarify exposure problems on the site? So that's a discussion I would propose the workshop have right now. One way to do that may be to open up an aerial photograph and talk about this would be an example that I have, and talk about the removal site evaluation, activities in the buildings, activities by the lagoons, the security team's activities, as well as the off-site impacted media team's activities. And this is a chance to discuss, how can our phase 2 sampling activities soil sampling, soil screening, and surface water sampling be performed in an intentional way to improve our conceptual site model and also to further clarify and further elucidate, to clarify exposure problems that may exist with impacted media near the wind process facility. This is the conclusion of this particular US EPA pre-recorded session. And I know it's going to be a good conversation, and I think it's going to be useful to talk about how these two activities, removal site evaluation and then phase 2 activities, can be kind of married together to successfully improve the conceptual site model and clarify exposure problems at the site. I'm going to log off my pre-recorded session for now. Thanks a lot for your attention as always, and I look forward to seeing you in the final pre-recorded session, which is removal action selection. Thanks a lot.
I just told them to just pause on this map because we probably gonna have to discuss based on this map. I think the first thing we should discuss about is that the 4 team which you want to combine because the task of like in my opinion, task of team 2 is too short in comparison with the team number 1. It's just like looking at like the berm of the lagoon. Probably like we can combine with probably like number 4 or something.
Yeah,
I propose that. I'm not sure.
Yeah, I think that's be okay because first of all, that I just try to kind of figure out how I'm gonna carry out this. Is it possible to print this out and distribute it to the team?
He counter proposed that just leave like the 4 station, and we have 3 team the same, but 3 team actually walk along 4 station, taking turns so that everyone can learn the same thing. I mean, if we separate, then some of the group will not be able to go into the factory or something. But if we separate into 3 group, but 4 station, and everyone begin from like their own station and take turn
Rotate.
So that like the first group probably start inside the factory and then look at the lagoon, look at the fence, and then look at the receptor. Another group may start at the receptor and then look at the fence and then go back into the factory. So it's to take turn, and everyone can learn everything, so that when we come out, then we update the CSM, right?
Yeah, and so I think that would be okay, but I'm not. First of all, I don't know how much time do we have inside, so it will be sufficient to kind of.
We have definitely entirely half a day, but we already plan to go in early. But a sad thing, if you can look around now we only have like PCD people. So probably tomorrow we might have to brief other department and the people who join. It's gonna be a big group because people who is in that area will be joining, like people from Industrial Estate Authority of Thailand. Instead of Zoom, they will come in by person, like Monterey office, like Ministry of Natural Resource and Environment, local office in that area will come in and join. So the group will be bigger. So we probably need to like let them join into either 3 of the group and then walk together.
We are expecting how big is the one group? Say 20 people or something like that?
Yeah, something like that. But
Right?
but I think
60
we are
total.
okay. I mean, if we tell like each of the TA, right, to basically control the time, right? I mean, when you walk around, you probably ring the bell or something and then walk out.
Okay.
Should be the one that is longest task will be the station one, right? Inside the factory. Because
Yeah, maybe we can actually, since there are 3 locations for one, for first, maybe we just take the one that at the right. I don't know which location is safer. Still, I think the safety is the most important. So we have 3 locations for one, and maybe we just pick one location that's for rotation. I think that on the upper right, while looking to the
we're looking
picture,
at
I
like
think that
probably
that
like
was very thin.
the left 2 zone is the burn. It's already burned, but the right one, the right block is not burned.
Oh, okay. So the right one is safer.
Yeah.
Okay.
The barrel is still stacked. In his opinion,
Okay.
it can
We don't walk in. That's fine, and we can just stand outside of the warehouse. Stand outside the warehouse and say you have to know. Yeah. So that's the first place, and the second location would be right by the lagoon, and then fence.
Then the receptor.
Receptor. Where's the receptor?
Receptor.
Oh.
No, but the receptor is a little bit tricky because I mean, to actually complete, then we have to actually walk around.
So we will have 3 groups, right?
Yeah, he proposed that.
Yeah, I think that's good. I think that's good. We have 3 groups, so we have three locations. And 3 locations, then we rotate, something like that.
Okay. Then I think we have 3 groups.
That's
three
yeah.
roles. But for our surrounding, I think we can take a car, like a receptor. We don't have, otherwise it's gonna be a whole lot walking around that entire block. So we if just 3 group and then 3 station, and then we come back to the car and then use the car to survey around the area. ก็จะได้ไม่ต้องเดินคือเขาบอกว่าให้ดูรีเซปเตอร์ด้วยแล้วก็กลับไปอัปเดต CSM ถ้าดูรีเซปเตอร์แค่เดินไปจุดที่1ไอตัวล่างใช่ไหมไอส่วนเลยเทียบกับไอหลังเลยแค่นั้นก็เดินชิบหายแล้วเพราะฉะนั้นเราก็เอาลบ
So the receptor will be kind of everybody is on the bus, and go around, and who will do the explanation? So somebody had to kind of explain.
Explain, yeah.
What should we know?
I think some of us should be able to explain. Or probably we do explanation at the local government office. So tomorrow, let's merge together. Tomorrow we're gonna leave from the hotel around 8 o'clock. So meet at 8 o'clock.
Okay.
Please, I think bring your bag for the people who gonna stay in New York.
Yeah.
Don't forget to bring your suitcase. Then we probably should go to the area around probably 10 o'clock.
Okay.
And we go directly to have a short meeting in the morning.
Yep.
Probably like 10:30 until noon at the local government office, so that we can prep everyone. So everyone will meet at the local government office. And then we have like a meeting room so that we can prep each other about safety gear or everything, right? Separate people into group, and then when we finish explanation, safety, everything, and like assignment. We go to have lunch from noon to 1 o'clock. Then 1 o'clock we go in and action immediately.
Okay.
Say, so we are going to visit the surrounding weather, right? But we still, station, this people do just the station. One is inside of it. One is the best area, right? Yeah, another one is okay, so these three groups can rotate. They rotate, yeah. And then they rotate together and something surrounding.
看现在看这一张哦，如果这张就是只有1、2、3。
Using it for that's fine.
Yeah, I think it's a good idea because I think otherwise if we group some
有一个
people
纯电
see
池
the
啊，
lagoon,
一个纯电
like,
池。
not come inside the factory, I think some of the people will be sad. They don't mind time, they only see the lagoon. It's not fun.
Need you enough to control the time to rotate the three groups.
Each every group stay at the one location say 10 minutes.
Yeah, it's being like
What did you say?
Walking is not that far, but I think the seriously not far, like
จากรั้วนั้นไปก่อน
300 meter, like I think 300 meter from number 3 to number 1, I think.
Okay.
But the only thing that gonna slow you down is that I think people will just like wow with like a one store inside, but if you like stop and then keep talking and then
Yeah.
fighting this and that,
That's
it's
not-
gonna take a lot of time
Yeah.
inside the warehouse.
No, not going into inside the warehouse. No. Just outside the warehouse. So each
Walk around the building, right? But not entering the building.
Yeah.
not go around the building after
The building is
another side of building the fence you can go
Mhm.
just go just inside the industrial
we
area
need to go through.
yeah
We need to go through.
ไอ้แต่ละ building เนี่ยเขาบอกว่าเราจะเดินว่าไอ้ building เบอร์อะไรเงี้ย
คือก็บอกทุกคนไว้ก่อนในฐานะเป็นโฮสต์ในฐานะที่เป็นเจ้าหน้าที่ด้วยกันแล้วเรามีแขกเยอะมากก็คือแล้วมันก็คงมีคนไม่รู้อีหน่วยเหน่เยอะนะก็คือเรื่องเซฟตี้นะเซฟตี้ก็คือดูคนอื่นด้วยไม่ใช่ดูตัวเราเองอย่างเดียวนะดูคนอื่นด้วยเพราะเราในฐานะโฮสต์เดี๋ยวเกิดไปทำงานนี้แล้วก็แบบว่าเกิดมีอุบัติเหตุขึ้นมานี่งามหน้างามไส้แน่นะทุกคนนะI'm just saying everyone to